Once again, good morning and welcome to our general mathematics class. Today we'll have lesson 3.2 and it's about exponential functions and introduction. Now, we're going back to chapter 1, lesson 1 on the introduction to functions. One of the types of functions is exponential functions, and it happens when the exponent is a variable. We will be dealing more on that in this lesson and also in lessons 3.3, 3.4, and 3.5. So let's now start. Let's start by reciting today's memory verse, and it's found in 1 Kings 4, verse 29. It says, "And God gave Solomon wisdom and understanding beyond measure, and breadth of mind like the sand of the seashore." At the end of today's class, you need to answer your MVCA boosters. And it's about Solomon's wisdom and understanding. The Lord exponentially blessed King Solomon with wisdom and understanding. In 1 Kings 4, verse 34, the Bible mentioned that people of all nations came to hear Solomon's wisdom and from all the kings of the earth who had heard of his wisdom. Here's your question. Why do you think Solomon was blessed with such wisdom and understanding? Why do you think the Lord made Solomon the wisest king on earth? Now, at the end of today's lesson, you'll be able to represent real-life situations using exponential functions. Now, here's a sample for the bacteria trouble. Roby left a slice of bread uncovered on the table for 1 minute. After a minute, he checked under a microscope and found 3 bacteria. In the next minute, there were 9. In the next minute, there were 27. In the next minute, there were 81. If the bread will remain uncovered for 10 minutes, how many bacteria will be there? Now, let's start with our lesson. Basic question, what is an exponential function? Now, an exponential function can be written as f of x equals b to the power of x, where b is a positive number greater than 0, but b should never be equal to 1. And x, the exponent, is any real number. Now, again, what are the conditions for b? B should be positive, or it can be between 0 and 1. It's possible. And b should never be equal to 1. Now, here are some examples of exponential functions. Remember, in the exponential function, the variable is found in the exponent. So example, the first one, variable in the exponent, your b is positive. Variable in the exponent, b is positive. Variable in the exponent, b is positive. So these are exponential functions. Now, what if we have f of x equals 1/3 to the power of x? You check. There's a variable in the exponent and your b is positive. So it's okay. Now, what are examples of not exponential function? You check. The exponent is not a variable. Therefore, it's not an exponential function. The second one, the variable, the exponent is a variable, but you look at the base, it's 1. So it's not an exponential function. The next, there is a variable in the base. It's not a positive number, so it's not an exponential function. So, ma'am, what if we have like this? F of x equals -4 to the power of x. This one, the variable is in the exponent, so check. But if you look at the base, it's a negative number. Actually, it's still an exponential function. It will look like this one. This is the main exponential function and multiplied by -1. What will happen if the graph of the first one is this, the 4 to the power of x? Because of the -1 multiplier, it will look like this one, going down. But still, it is an exponential function. As long as your base should not be 0 and it should not be 1. Why is it not possible? Because if your base is 0, whatever the exponent is, if the answer will still be 0. The same with 1. If your base is 1, whatever the exponent is, the answer is still 1. And it's not okay in exponential functions. So let's go to the next one. Now, what is a characteristic of an exponential function? In an exponential function, the value of your y increases rapidly or it decreases rapidly. Now, in a linear function, like this one, f of x equals 3x, the increase is constant. Like I look at the value of f of x, okay? 3, 6, 9, 12, 15. The value is constant. You just keep on adding 3. Or another one, we have x squared. Y equals x squared. So you have 1, 2, 3, 4 for the x, and your y will go 1, 4, 9, 16. Now, we look at what's this? The increase is still constant. It's in the x squared. But if you have an exponential function, the increase or the decrease is very rapid. Example, if we have f of x equals 3 to the power of x, we have 1, 2, 3, 4, 5 for our x, but you look at our y. 3, 9, 27, 81, 243, like that. It increases rapidly. Now, what are some examples of exponential functions in real-life settings? Example number 1, number of infected patients of COVID-19. If we heard from the news, it starts with 2, but later it becomes 27, then 100, 1,000, then thousands. So you see, the growth is exponential. It's not just linear. It shoots up immediately. Or another, population. Population is exponential in nature. Increase of bacteria. Remember, if you have you don't have your biology class this time, but in your junior high school biology, you have talked about the meiosis and the mitosis. Like one cell would break, and then another would break, and would break. So that's it. The concept of exponential functions. Another, when you invest your money and it's in compounding interest. Now, the opposite is simple interest. Another, the half-life of a substance. Like you still have this amount of sodium this time, but after a few days, it will constantly decrease exponentially. And another, the death toll or the death rates in the Philippines, it's still exponential in nature. So again, when the increase or when the decrease is rapid. We just say it's not just a constant variable, but it's a rapid one, then we call that an exponential function. Do you have any questions?